summary. So maybe Richard, yeah, again.
Now you can hear me. Yeah, I'll switch to the notes.
Mm-hmm.
And so as usual, at the very bottom, there's the feedback of the day. And not just the day, I guess this should be for the whole course.
Mm-hmm.
Do we have
The
two feedbacks, one for the day and one for the course?
If
Well,
someone wants to duplicate it twice, you can, but usually it's just one.
No, let's go with one.
At least for this part. But then now for general Q&A. So now's the time when we can all be here and we'll just reflect on the course itself. Yeah, so who remembers at the beginning when we said that it was impossible to teach everything that was needed in a what's it called, in a 10-hour
HPC system?
course?
Well.
Yeah, so I still think that's true. And I mean, here in this course only, like, and we can only had time to give you a summary, do some examples and so on. But by no means do we think that this course is the end of what you need and all. It's just a starting point. It basically, hopefully, lets you realize what's possible, and and have had the initial experience with stuff. And now, you will know when and how to go read for what comes next. What do the other instructors think? Was it?
Yeah, like I think like I don't remember like when was the last time first time I was doing this course back in like 2016 or something, and like the ecosystem has changed dramatically from those times. Like if like, and don't be afraid of like thinking that okay, this is a lot of stuff happening, because it's a lot of stuff happening for everybody. Like
Yeah.
like back then it was basically like we wouldn't have even the, like, let's say the GPU day at all, like basically, because the GPUs weren't like they were being utilized but not in this sort of a level. And many of the concepts like AI and whatever, they went like things that are happening constantly.
Yeah.
So there's a lot of stuff currently happening in the space. Like the computational space is getting very complex, but at the same time, it's I would say that it's good to differentiate. Like there's like if you have certain things that you need and you want, it's good to like know that okay, I don't need to necessarily know everything about everything. Like you can focus on learning those things that you need for your work, and then learning the rest later.
Yeah. Yeah, so some of these questions. The first question is about COMSOL and how to get started. What would you all think?
Depends on your time limitations. I would suggest coming in on one of the COMSOL focus days that we have in Garage, because then there are plenty of experts here that have a lot of knowledge with COMSOL and also a lot of detailed knowledge on how COMSOL exactly works. While if you come in on another day, we do have a few people that do know about COMSOL, but you might be unlucky and well, not get the right person on that day. But it doesn't hurt to show up any other day, and you're welcome to. But it's just possible that we might not be able to help you on the spot.
And like I would say that COMSOL is one of these kinds of programs that like once you get it sorted out and it works, it works. Like it's the kind of a program that like because it has like this, like you can submit it straight from the like the graphical user interface, and then it just runs stuff on the background and you don't need to think about it. But to get it working, that's the problem. And that's usually like like it's good idea to ask for help, because like it's not fun doing it by yourself based on just looking at the manuals.
Yeah. And it's the kind of thing that like you'll always find people that know about the cluster itself, but might not know all the buttons in console. So if you can get it most of the way there and show us an error message that comes from the cluster, you can probably get help almost any day. But if it's not that, then not. Next question is also pretty good. So a custom library which is not written for Triton, not available, and the default instructions don't work on Triton. So, yeah, what would people do there? I guess
That is a very hard one.
what's the name of the library? Like, is there a public link or something? Is it a common library?
But
so
yeah,
if it's
like
So
Yeah,
I
right.
would say in general, I would say, yeah, come to Garage and let us have a look at it together. I would say it really depends on what kind of library it is. If this is something that is, for example, pip or is a Python library, then you can normally just do it yourself if you know enough about Python, so that you can just run the code from a customly installed library. If you don't, also come to Garage. We can try to help you there. And if there are no really strange things happening normally, we get the things running.
like
But yeah.
Yeah, like quite often, like especially for scientific coding and scientific programs, like for the whole ecosystem, like the Linux ecosystem and stuff like that, like the GNU ecosystem and everything related to that. There's like standards that are very like engineer focused, but they follow them very well. So they have like usually like if you have a like code, you have certain like configurations or configure flags or whatever, and you can like spot the pattern and use that. But the unfortunate thing is that because it's so engineering focused, is that like I remember one CMake manual, like tutorial from those people was like 500 pages. So it was like insanely long, like all of the tutorials, but it's very strict and very like regimented, and everything is where it's supposed to be. But when it comes to scientific programs, like nobody has time to read those 500 pages, so you might end up that the scientific program, it doesn't follow those standards like completely, so it becomes kind of like a translation problem where you have like, okay, this is what the creators of the program like intended to be done, but they use like different names for the flags or whatever, and now suddenly like you need to do this kind of like translation. Okay, what did they like this XY problem kind of a situation? What did they want to do, and what things that the installation thing need, and like it becomes this kind of like guessing game. You need to go through the source usually and check, okay, what it actually tries to do, and sometimes getting like outside feedback on this, it can be really helpful, like somebody else who has done enough of the pattern recognition to see that, okay, like hey, they're probably trying to do this kind of thing and they mean these and these things, and sometimes that can happen with many libraries.
Or even just knowing where in the error message you actually have to look for what the actual error message is, because you get like 3 pages of outputs, and if you don't, or if you haven't done this before, you're stuck with, okay, this is so much stuff, I don't even know where to look for things, and there's 1,000 different warnings, errors, and stuff, and and we kind of have seen these things, and we know which things are important and need to be considered, and which ones are, this is just standard output that it always prints.
But I would also say that I wouldn't discourage you to try like checking out the pattern recognition yourself. But the problem, like the important thing to realize that the problem often necessarily isn't in you. It might be that like somebody misheard something 5 years ago and now it's in the code. Like now it's like there's this game of telephone that happens with like programs, and like sometimes somebody like doesn't follow a standard or something, and then it gets baked into the code and everybody uses the code already, and now it's like a standard in the code, but you need to know about it, and it's like hidden in a readme 5 pages deep, and it's like it's not necessarily your fault that you didn't recognize the pattern, or you didn't know about this, or you didn't know about the thing. But what you can try, like at least I do, is that like if I see something, I'll usually go back to the source and check like okay, how is this supposed to be written? Like let's say like how are they expected these flags to be given, and why aren't they given like they are, and what flags they want to give, and that sort of stuff. But it becomes this kind of like it's very hard to say how do you recognize these things, like what Thomas said about the error messages. It's very hard to say how you spot the right line in the error message, and it only comes through time. But it's not the problem that like you're wrong because you didn't understand it. It's the message is always can be bad. Like the error message can always be bad, but you just like plow through it. At certain point, you just know to look for a certain place after you encountered it more and more times. So it's like, unfortunately, it's sometimes like that. But so I would encourage everybody to just also try it out. Like just try reading it and try Googling as well. Because after a certain time, you get accustomed to seeing those patterns.
Just where you mentioned this has become standard in the code, or there is something that is happening. It might also be good if this is a project that is hosted on GitHub to just look for something similar or something where you think this could be related to in the issues. Because often enough, there is an issue from 5 years back that why the heck is this the default? This is completely unintuitive and not documented anywhere. And could this please be changed? And yeah, it just never was.
Yeah.
And I have a personal example for that from a Microsoft library.
Yeah. And my comment on this question, when I see there's an install.py file, that's not the standard name of a package project thing. So if it was setup.py or pyproject.toml, I'd think, okay, most likely I can make a virtual environment or conda environment and run a command and it will install it and mostly do all the stuff automatically. I might need to tune some, but not. But install.py makes me think someone has written a custom script that tries to install it. Who knows where it installs? And if I need to do it myself, it's probably going to be a lot of manual work in figuring out how they did it. So of course, like if you're using this, there's nothing you can do now, but this is a lesson for the future. So when you're releasing something, it's worth taking a little bit of time to understand how the project, how Python stuff is supposed to be packaged and so on, and then do that if you want people to use it. We actually have other courses in the Python for Scientific Computing course that's usually in the autumns. There's a session where we very briefly talk about the packaging standards, and it's not that hard.
And I want to add on that, also to consider what should be happening in an installation script in Python and what should not. Like things where Python assumes that underlying system libraries are installed. So your installation script should not try to install system libraries because that is always operating system dependent, and Python says no. I don't want to do this. This is something that the user has to take care of in a different way. Conda, for example, does a lot of wrapping around that and adds some things that are system libraries in the environments, but don't try to do this in a custom installation script. You will just most likely make it extremely complicated for someone else to actually install it.
Yeah. Yeah. Yeah.
But like
Any other?
again, like I
Go
will
ahead.
quickly mention that the like again like, but it's often like also high burden like to like think that okay, this needs to be perfect and whatever, like first time like if you want to do something and you want to publish it, don't worry if it's bad the first time. It's like it's the continuous process of improvement that matters more. So like I have published code that is really bad, and I have like made repos that I still look back and think that okay, like these are bad, but they were bad because I didn't know better but at that time. So like you will go through the process, and like that will happen for everybody. Like everybody will publish code that is not using the standards. It's missing something that you realize later that hey, I should have used this and that, and like don't put too high of a like also like a burden on yourself, but in the next iteration know that okay, like maybe I shouldn't like use the previous one, maybe I should try improve in the next iteration.
Yeah. I sort of say something similar. So you don't have to be perfect, because perfect is always too far away. Just try to do a little bit better each time you do something. And then once you like if you do something often, you'll get better at it and reach the level you need. So what I mean, okay, so for the feedback parts here, it looks pretty similar to other days. Yeah. So what should we recommend people do next? So what we covered was in the schedule. There's a lot more written material to review.
Yeah, like at least I would recommend just trying out whatever you are planning on working on. Like it's like if you have a bunch of cookbooks in your bookshelf, but you never go to the kitchen, you will never learn how to do like cook food. Like you really need to go to the go to the place and start cooking and tasting the food for yourself. And then of course use the cookbooks as this kind of like reference point that okay, it should look like this, but why my food doesn't look like this? And then you're like you can do the improvement procedure. But like I would highly recommend that you pick a program or thing that you want to do in the cluster, and like first let's say you have a program that you run currently on your laptop, and it let's say you heats up your laptop and you can't have it in your lab anymore, like it's too hot because it's constantly running some program. Like can you move that to the cluster, and what does it require from you to do that? And try out like would it be possible that it heats up the computer in a machine room somewhere so that your computer isn't overheating? So try like some program, move it into the cluster and get accustomed to the workflow that you like basically put something running somewhere else and you don't have to worry about it anymore.
Yeah, that's a good way to do it. What courses would you recommend people to follow up next with?
Well, on the autumn we have the Python for Scientific Computing coming up. Again, like that's our course, and there's also the Code Refinery course coming at some point. They are good ones, of course.
Yeah, I think Code Refinery is mid-September now, so I guess you'll get links to this in your email if you've registered. Python for and Code Refinery and Python for SciComp are a lot of these same kind of instructors and the same teaching style, where it's live stream with the notes to ask stuff and lots of exercises and so on.
Yeah, the focus is more on the workflows and how to use Git and that sort of stuff. And
yeah,
and improving your productivity, basically.
Yeah. Should we discuss any feedback? Yeah.
I think the feedback is good and honest, and like
Yeah.
it's always complicated with this course, and especially with the time frame, like how to get everything into the
Yeah. And there's like this thing we struggle with for every course. So we make it like advanced enough to be useful, then it excludes most of the people that could benefit from it, and is basically saying do all these other more basic courses before you can get to what you need. But with today's academics and so on, like the academic system and the time pressures people have, people just don't have time to do a ton of prerequisite courses before they start getting stuff done. And that's why we emphasize the big courses that sort of set the basic level, ways for people to study what they need themselves, and then also our help, so we can help you with the specific parts that you need help for, and sort of like one-on-one working together. So time's up. Are there any final